All right. We are on 3-4. This is the last section in chapter 3. Tomorrow will be a make sure all your homework's turned in, do some ACT practice day. We'll review Monday and take a test on Tuesday. All right, so we've learned all of the pieces. Now we're going to find zeros of polynomial functions. So the rational zero theorem is a way of finding all of the possible rational zeros to a polynomial function. Again, this is something that is pretty obsolete these days. It's good to kind of have in the back of your head when you're using the calculator to find zeros, when you're trying to find ones that aren't pretty, just to make sure that you think that they do make sense. But we're going to rely on our calculator to help us out. But it's good for you to understand the rational zero theorem. So to start with, we're going to do a couple examples of that, maybe one. So the rational zero theorem says that all rational zeros are of the form P over Q, where P is a factor of the constant and Q is a factor of the leading coefficient. So an example of that, if I asked you to list all of the possible rational zeros, which I think is going to be maybe the first question on your homework, then you look at the constant and you look at the leading coefficient. You list out their factors. So the factors of 2 are 1 and 2. And we put plus and minus because if I could do a positive times a negative to get that negative 2, right? But for a positive 15, I could do a positive times a positive or a negative times a negative. So we don't know the sign, so we just put plus or minus on everything. All right, so once you have the factors of the constant over the factors of the leading coefficient, then you break it down to all of the possibilities. So I could do 1 over 1. I could do 2 over 1. 1 over, I don't know what I'm doing. My pen's not going well. I can do 1 over 1. I can do 2 over 1. I can do 1 over 3. I can do 2 over 3. I can do 1 over 5. I can do 2 over 5. I can do 1 over 15. I can do 2 over 15. So I get all of these guys. All right, so there are 16 possible rational zeros. You see 8 listed, but positive and negative of those, so 16. All right, so the actual solutions, we know there's only 3 altogether, and they may or may not all be rational. They could be irrational. But this tells you that they are all rational, and they all come out of that list. All right, so can you list all of the possible rational zeros? All right, so P is 6, Q is 3, so factors of 6. I'm not going to put the plus or minus until the end because I'm kind of lazy. We could do 1 times 6, we could do 2 times 3. For 3, we just have 1 and 3. All right, so I could do 1 over 1. I could do 1 over 3. I'm going to do each of these over these. So I'm going to do 1 over 3. I can do 2 over 1. I can do 2 over 3. I can do 3 over 1. I can do 3 over 3, but that's just 1. I can do 6 over 1. I can do 6 over 3, but that's just 2. So there's my list without repeating anything. Alright, so when it comes to finding all of the zeros, what you're supposed to do, list all of your P's and Q combinations, all of those possible zeros like we just did on that last screen. Then do synthetic division and with different ones of those possibilities until you get 0 as a remainder. We don't need to do that now because we have a calculator. So again, I can't show you my calculator screen. So I'm going to tell you what I'm doing on my calculator, and hopefully that will suffice. All right, so n y equals, we're going to go put in the function. All right, we're going to hit graph. And we're going to look at where the graph crosses the x-axis, and we're going to pick 1. And from there, we should be able to work the problem. Sometimes you got to go back and pick a second one, but usually you don't. So we're going to pick a 0. So looking at my calculator, the graph looks something like this. Alright, this probably goes like way, way high up, but we'll pretend. Alright, so it actually went through perfect right here. So it looks like it goes through at -5 and maybe like, I don't know, a third or a fourth or probably maybe a sixth. Looking at what my P's and Q's would be, like just thinking of them in my head. So I'm going to pick the -5 because that one I'm sure of. So from my calculator, I think that there is a 0 at -5. So we're going to do synthetic division and see if we get 0 as the remainder. Because if we do, then we know that at -5 is an x-intercept or a 0. Alright, so 6 multiply, that's -30, add, that's -5, multiply, that's 25, add, that's 1, multiply, that's -5, add, that's 0. So we were cubed, so now we're going to be squared. And I have a quadratic. So remember I told you yesterday that our goal is to whittle our polynomial down to a quadratic because we can solve from there. So my hope is that it factors. But if it doesn't, the quadratic formula is always an option. I think I need 6 and 1, right? Because you have to use 1 and 1. So, no, that's not going to work because I have to have matching signs. So we're going to go 3 and 2. Because that way I can go negative, negative, and that'll give me -3, -2, which is my -5. So if this is 0, then x is 1/3. And if this is 0, then x is 1/2. Oh, I know what it is. On my graph, it's not zoomed in enough, which is why the graphing calculator is not an end-all be-all. I was looking at the picture on my graph. If I zoom in on this little spot right here, then you realize that it actually dips below a little and comes back up, so it crosses at 2 different places right there that I couldn't see when I first graphed it. Alright, so we have found all of the zeros, but you will lose points if you don't list the one that you found with the calculator, so make sure that you do that. Alright, so another example. There we go. So let's see. We know we're going to want to do synthetic division. I'm going to go ahead and set that up. And typing it in the calculator. We have x to the 3rd plus x squared minus 5x minus 2. Alright, so looking at a graph of that. So out of your calculator, you should have something that looks like I'm trying the best that I can to get a good picture. This goes something like this. And this goes like this. So it looks to me like it goes through 2. It's the only one that's pretty. Maybe -1/2, maybe whatever that is. But it looks like it goes through 2. Alright, so synthetic division is the way that you test that. And it works. It was cubed, so we divided off a factor, so it should be squared. Alright, so here's the thing when you look at this one. That one's not going to factor because I can't multiply to get 1 and add to get 3. So, you've learned other ways, quadratic formula and completing the square. I don't care which method you like better, pick one. So remember that the quadratic formula says that, I don't know what x equals. I changed my mind halfway through what I was saying. if you have this, then this is true. Alright, so we have 3 in the place of B, 1 in the place of A, and 1 in the place of C. So it looks like that. So I'm going to come this way so it all fits on the screen. So we have -3 plus or minus, what is that, 9 minus 4, so 5 over 2, and none of that simplifies. So my solutions are +2 and the 2 irrational ones, which I thought was that there. Alright, so we have these are not irrational. Yes, they are. Sorry, wrong word. Or that word. You have 2 irrational solutions and that 2. And those make up your 30. So these are actual x-intercepts. They're just gross x-intercepts. So if I typed this in my calculator and got 2 different decimals, -3 plus root 5 divided by 2 and -3 minus root 5 divided by 2, I would get something around 0.4 and something around -2.5, 2.6. All right. I'm going to delete that. I thought I had deleted that actually. Okay. So, I don't know what happened there. Okay. So, on this assignment, the book is going to give you a set of directions, but on 10 through 24, remember that you can just use your calculator to get your first 0, and then you can solve by hand from there. Like always, if you have questions, please let me know. I'm happy to help.